Hey class, this is Mr. Roberts, Shasta High School, and we're going to be looking at some homework problems from chapter 9, starting with question 70. I apologize, I'm recording without my headset, so I hope the audio is not terrible. I left them in the classroom and don't have them available. So, question 70 says, graph the system of inequalities below. Now you can see that there's two equations making up what is a linear system, right? We've got y values are greater than or equal to 2x minus 4, and y values are less than x. We're asked to shade the solution region and also to check out the point 0, 0. So let's go ahead and start. So the first equations, I mean, obviously these are simple. We've been doing this for a long time. So we've got a y-intercept at -4 and a slope of 2. So from here, I'm going to go up 2 over a single unit, up 2 over a single unit, up 2 over a single unit. So you get the idea. That is the boundary. And this boundary is going to be solid because it did say the y's were greater than or equal to it. So when I line the ruler up here, I'm going to go and just pull a line that goes all the way through. It's not a dash line. And the other thing is, this does say y values have to be above that curve. So I can pick any point I want to. Like, for example, I could pick the point 1, 1. And I expect that's going to make this inequality true. So if I think about it, in that point, x and y are both 1. So I could just substitute in here and check. I've got a 1 for y and 2 times 1 for the x and -4. Well, 2 times 1 is 2, 2 minus 4 is -2. So this actually ends up becoming 1 on this side and a -2 on this side. And it says, I don't know why that became a 0. Oh, ink shape's on. Let me turn that off. So I end up getting that I get that 1 is greater than or equal to -2, which is totally true. So I know that I'm shading the right side, right? So I am everything above this curve. It's about y values that are above this boundary, above this boundary. The other one is y's are less than x. Well, y is equal to x is fairly easy to graph, right? In fact, the point 1, 1 is a point on that graph, as is 2, 2, and 3, 3, and 4, 4. And 5, 5, 5, and -1, -1, and -2, all of those. Now this did not say, or equal to, it was just the boundary. I think y's were less than this. So this is I'm going to draw as a dashed line, indicating that all of these points on this boundary are not part of my solution. And it did say y's were below that. So if I was to pick and just test a point like, I don't know, this one right here, -2, -4. So that point I've selected -2 for x, -4 for y. There's x, there's y. And if I'm checking out y's are less than x, I think that should work. If I plug in the -4 and if I plug in the -2, is it true that -4 is less than -2? Of course it's true. -4 is smaller than -4 is smaller than -2. So here we're shading everything below this boundary. So what are we looking at? We're looking at all the points that live in this region here, right? Below the y's are below the y's are less than x, and above the other curve, which is 2x minus 4. The other thing it asks me to consider is the point 0, 0. It says, is 0, 0 a solution to the system? Well, the problem with 0, 0 that I can see is that it actually lives on this one boundary. And points on that boundary are not solutions. So if I was to plug in 0, 0 into both of these equations, I think in the first equation, right, we'd have 0 here and a 0 here. Well, clearly, 0 is greater than -4, so that's not the issue. But the problem is below that, when I put in 0 for y and 0 for this x, it's not the case that 0 is less than itself, right? So 0, 0 is not a solution because it doesn't make that second inequality true. So my solution ends up being just this region. Any points that I pick in that shaded region would be a solution to the system, meaning it would satisfy both of the inequalities in it. Question 71 says, it's multiple choice. It says, which of the points below is a solution to the absolute value of y is less than x minus 3. And I'm just going to start by plugging in some points and seeing what we get. Remember, for any ordered pair, of course, we have an x value and we have a y value. So we'll just go ahead and look at these. I have to keep this on screen so I can see it. So y is 1. So the question is this true, right? And this is, I'm not asserting it's true, I'm asking, is 1 less than the absolute value of 2 minus 3? The absolute value of 2 minus 3 is negative 1, right? And the absolute value of negative 1 is just plain old 1. So the question is 1 less than itself? And that's false, right? So immediately I know that A is not an option. But what about B? On B, we've got 5 for our y value, and the question is 5 less than the absolute value of negative 4 minus 3? Well, negative 4 minus 3 is negative 7, so we're looking at the absolute value of negative 7, which is 7. Is 5 less than 7? Yes. So B is a solution. What about option C? So again, same thing, I'm plugging in my y value. I've got 8. Is that less than the absolute value of negative 2 minus 3? That's negative 2 minus 3 is negative 5, so I'm looking at the absolute value of negative 5, which is 5, and the question is 8 less than 5? And that's false, right? 8 is not less than 5. So C is not an option. It did say multiple choice, but it said which points, so I'm going with maybe there's multiple points. So I'm going to check D also. And when we check D again, we're going to write down that 3 is what y is, and I'm wondering, is the absolute value of 0 minus 3 larger than 3? Well, this ends up being just 3, right? The absolute value of negative 3 is 3. 3 is not less than 3, so this is false also. So the only point that worked was point B. Moving on to 7D2. Write and solve an inequality for this situation. To honor 50 years in business. Well, that's fun. This is the 50th anniversary of Shasta High School Musicals, but that's not a business. That's just something Shasta does every year. To honor 50 years in business, All Strikes Bowling, a beautiful bowling alley, is having an anniversary special. Okay. Shoes, and I guess that means both the left and right, rent for $1.25, and each game is 75 cents. If Charlie has $20 and he needs to rent shoes, how many games can he bowl? Well, I'm going to start by declaring what a variable is, right? I just want to be really clear to myself. I'm going to say let X be games. What does it say? Games bowled? Is that a word? I guess I'm going to leave it there. Let X be the games bowled. So that means that this expression that I'm writing, $1.25 for the rentals plus 75 cents for each of the games, right? This expression is equal to how much money he spends if he plays X games. And we know that there's a constraint on this. He cannot exceed the $20. I'll say it can equal 20 exactly, right? If it comes out to a nice whole number, it could be equal, but it can't be, it has to be less than $20. So again, this is the money that he has. He has $20, and the amount of money that he's going to spend has to be less than the amount of money he has available. So if I solve this inequality, right, I would begin by taking away $1.25 from both sides. So I get 75x is less than or equal to 20 minus $1.25. And then I'm going to divide both sides by 75 cents. So the amount of games he can play is equal to 20 minus $1.25 all over 75 cents. There we go. That's our answer. Of course, it'd be nice if I could evaluate that expression. So let me grab a calculator here. So we're looking at 20 minus $1.25. So my numerator there is $18.75, and I'm going to divide that by 0.75. When I do that, I get 25. And it's not $25, it's 25 games. And apparently, so X can be less than or equal to 25. Or what it is, it's games, G-A-M-E-S. So he can play 25 games. That seems, whoa, that's a big calculator. That seems more than I thought it would be. So I'm going to plug that in and just verify that I get $20 as the boundary when I plug that number in. Oops, where did that calculator go? There it is. So if I take $1.25, that's the shoe rental, plus 25 games times, oh, no, 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 no. I got to be careful. This is standard. This calculator is not scientific. Let me jump to scientific. You always got to be kind of paying attention to what your calculator does. And that was not doing order of operation. I could see that. So this should, I'll take $1.25 now, and I'm going to add to that 0.75, 75 cents times 25. So you can see it didn't do this. It's waiting to do this multiplication and then add the $1.25. And I get $20. Yeah, so he can play up to 25 games, including 25 games. Let's get back up here, but not more than that. Oh, please. All right, let's move on to question 90 or 73. It says solve the system of equations below algebraically. Sweet. Okay. I guess we could go. I guess we could do a little work and go elimination. We haven't done that for a while. So let's. I haven't done that for a while. So I'm gonna choose to use the elimination method. I don't think we've done a problem like that in class. I'm going to do two things. I'm going to rewrite the first equation. I don't like the order that things are in, so I'm going to change that to. I'll change it to negative 3y plus 2x is 12. So I've just reordered the negative 3y and the 2x. And I did that because I want the x and y's in the same order below. So I'm going to take this second equation, I'm going to multiply both sides of this, the left and right hand side, by positive 3. When I do that, you can see I'm going to eliminate the y variable here. So this is going to become 3 times y plus 3 times x, and that will equal 3 times 9, which is 3 times negative 9, which is negative 27. Negative 27. So we're all set for the elimination here. So let's go ahead and do this. Remember, the thing is I've got equal things, and on each side, what equal things? This is a statement that says the left hand, right hand side are the same. These are equal. And to each side of those equal things, I'm going to add equal things, right? This expression, 3y plus 2x is equal to negative 27, so we're adding that. And when we do that addition to both sides, we get 5x over on the left-hand side, and we get negative 12, oh dear, negative 12 and 27 on the other side, which I'm pretty sure I just said backwards. We've got positive 12 and a negative 27, and when I combine those, I get negative 15. So that means that x should be the number negative 3. And now that I know what x is, I need to calculate y. So to get y, I think I'm going to use the original equation, right? This one right here before I multiply by 3. So y plus x, well, we just found out x was negative 3 equals negative 9. So y should equal negative 9 plus 3. So y should equal negative 6. So our solution appears to be the point x is negative 3, y is negative 6. Of course, I know I make mistakes all the time, and maybe I made one here, so I'm going to run through and check it. And I think I'm going to go ahead and I'm going to use my calculator just because I feel fatigued. So clear. So I'm going to go 2 times negative 6, so 2 times 6 negative. There we go. And then I'm going to subtract from that 3. No, it's 2 times negative 3. I'm fatigued and I'm already getting this wrong. Let me try again. 2 times negative, you know what, forget the calculator. Let me just write this out. So in the top equation, I've got 2 times negative 3, and I'm going to subtract 3 times negative 6. So 2 times negative 3 is negative 6, and negative 3 times negative 6 is positive 18. And if I combine negative 6 and positive 18, I get 12, which is great because that's what it was supposed to be, right? It was 12. So it definitely checks in the first equation. And then let's check in the second equation. Oh, I could do that. Look at it. It says add your y value, which is negative 6, plus your x value, which was negative 3. And when I combine those, I get negative 9, right? Which is exactly what it was supposed to be. So this point, x is negative 3, y is negative 6, is the solution to that system. Let's move on to question 74. 3 years ago, 3 years ago, that means in my past, and not today, and not tomorrow, but 3 years ago, the average price of a movie ticket was $8.75. Okay, and now it is $10.87. What is the annual multiplier and the percent increase? Sketch a graph and make a table for this situation. I actually want to organize this with a table to start with. So if X is the number of years and Y is the cost of a movie ticket, it says 3 years ago, well, here's year 0. And apparently at year 0, which is now, it's $10, no, not $18. It is $10.87. 1 year ago, 2 years ago, and 3 years ago, and I've left myself no room at all to do this. This is terrible. And maybe you can. I just can't. I can't do that. It's just, let me try this way: negative 3, negative 2, last year, this year, next year, 2 years from now. This year it is $10.87. And 3 years ago, it was $8.75. So there's two values that are missing from this table, right? And if I want to figure out my multiplier, I know that I'm going to start here and I'm going to multiply by it once, I'm going to multiply it by it twice, and then I'm going to multiply it by a third time. So I'm going to be multiplying by my multiplier 3 times. And remember, we're looking at y equals ab to the x power. B is the multiplier. I don't know what that is, but I do know that A, my 0th value, is 1087. So I can write this. I can say Y is $10.87. I'm going to go times B, which I do not know, but I'm going to raise that to the negative 3rd power. Now, when I raise that to the negative 3rd power, right, all of a sudden I know that I'm talking about the year that the movie tickets were $8.75. So that's my Y value at that point. So let's go ahead and say $8.75. So I need to solve this, right? And to solve this, first of all, I'm going to go ahead and divide both sides by 1087. So I get $8.75. I'm going to divide it by $10.87. Okay. And then that's going to equal B to the negative 3rd power. So we've been talking about this with roots. I'm going to think about this in terms of a fractional exponent. So to solve this, I'm going to raise both sides of this to the not the negative 1/3. I mean, not the positive 1/3. I'm going to raise both sides of this to the negative 1/3 power. And I hope you can see why. I hope you can. So to the negative 1/3. The reason why I'm raising it to the negative 1/3 power is on this side, when I have the negative 3 times negative 1/3, that's going to give me an exponent of positive 1, which will let me figure out what B is, right? That's what I want. I just have to do the thing on the other side. I have to raise that to the negative 1/3 power. No idea how. I don't have my on-screen calculator installed. That's why I'm using just the Windows calculator. I have no idea how this is going to work out, but let me try it. So I'm going to take $8.75. I'm going to divide that by $10.87. Oh, no, that's a mistake. $10.87. There we go. Equals. So I got that crazy decimal. Now I need to raise that to a power. So I think I'm hitting this arrow. No, that's not what I wanted. oh, it's x to the y. I'm going to raise that to a power of, open parentheses, 1 negative divided by 3. And I can see up in the thing above this is doing the right thing. So I've got something raised to the negative 1/3 power, and I press equals, and it says 1.0. Let me write those down. It's giving me 1.07. Oops, get back up here. 1.0749. I'm going to put this to 7.5. Okay. So the multiplier is 1.075. That's what I'm multiplying by every single time. That's my value of B. And then as far as the percent increase, well, the percent increase, I would say, I'm going to round it to a whole percent, is 7.5% increase. So you can see right in here, right? Once I subtract the 1 and move my decimal place over 2 places, every single year the price is increased by 7. It seems high to me. Is that really right? 7.5%? Because if I was multiplying by, if my multiplier was 1.2, it'd be by 20%. So yeah, it is. It's 1.7%. So, I mean, 7.5%. So my answer to my question is my multiplier is 1.075, and I am increasing by 7.5% each year. Okay, 75. It says solve the following equations for x. Great. Great, great, great. First equation, I'm going to add 6y to both sides, so that gives me 4 times x is equal to 20, and then plus 6y. Now I'm going to divide by 4, so x is 20 plus 6y divided by 4. Now it turns out that numerator, there is a common factor of 2. Yeah, both of those terms in the numerator can be, they have a common factor of 2, so I'm going to clean this up. That's a fine answer, but I'm going to divide the numerator, I'm going to divide this factor of 2 out. So 2, that's 2 times 10 plus 3y, and my denominator is 4. Now I can see that there's a common factor of 2 in the numerator and denominator. So my answer that I'm going to write is going to be 10 plus 3y all over 2. And I don't know. I don't know that that's necessary, but this is a fine answer too. But of course, if you look online, you only saw that answer in the textbook. It'd be nice to know that they're equivalent. So that should be A. Let's take a look at B. For part B, I'm going to multiply both sides of this by the number 2. And if I look at this, it's a little tricky, right? This side, there's only one term, right? Because there's a multiplication problem here. There's just a single term. Now, it's true. It's one term that contains 2 factors. One of the factors is the fraction 1/2. And the other factor, right, is this binomial x minus 6. But it's still just a single term. So when I say I'm multiplying both sides by 2, right, I'm only going to multiply the 2 times the 1/2, right? That's the way I'm going to tend to do it. I'm not thinking about multiplying both of those factors by 1/2, just the one factor. We only multiply separate terms by that same value. So anyways, what are you saying? I'm saying I can write this as multiplying both sides by 2. I can write this as x minus 6 equals 18. Or if I add 6 to both sides, x would equal the number 18 plus 6 is 24. Now what's nice is, like, I've done this, right? And I've made this whole thing where I've asserted that I multiplied both sides by 2, and then I can check it, right? 24 minus 6 is 18. Yep. And 18 times a half is 9. Yeah, that works, right? That's it. Let's move on to part C. We're going to solve this for x again. I'm so happy that they're doing this so that I can see that there's an example here where x is in my denominator. So for this one, right off the bat, in fact, I'm going to show it up here. I'm going to multiply both sides of this by 5 times x. It gets over 1. So every single term on both the left and right hand side is going to get a factor of 5x in the numerator. there are two terms on the left-hand side, and they both need that. So this left-hand side I'm going to rewrite as 4 times 5x over 5 plus 18 times 5x over x, and that's going to equal 8 times 5x. So oops, get that ruler out of the way, 5x. So I hope you can see that I did indeed put a 5x in every single one of those terms, right? This is multiplication. So there are some common factors that we can, like some giant ones. So I've got this 5 over 5. That's a giant one. I've got this x over x, which is also the number 1. So I can clean this up and write this as 4x plus 5 times 18. 5 times 18 is equal to 90. And that's going to equal 40x. I'll take away 4x from each side, so I've got 90 is equal to 36x. I'm just going to take 90 and divide it by 36, and I get 2.5, right? Which I would probably write as 5 halves. So x is 5 halves. Now, that probably is worth me attempting to check that one. So if I take 18 and I divide it by, I'll go open parentheses, 5 divided by 2, close parentheses, plus 4 divided by 5. I should get the answer of 8. And I do, yeah. All right, last question here. Oh, look, it's a friend, an absolute value equality, right? So our strategy is always to have the absolute value portion of the problem alone first. So I'm going to subtract 2 from both sides. And I'm going to rewrite this as the absolute value of 2x minus 3 is equal to 3. And remember, looking inside, there's two things that this expression inside can be, right? Either it is the case that 2x minus 3 is positive 3, in which case the absolute value of that would be 3, or it is the case that the thing inside, the 2x minus 3, is negative 3, and if it was the negative 3, the absolute value of that would give me 3. So those are the two situations that are possible. Both of these have the same two steps. I'm going to add 3 to both sides and divide by 2. So this becomes 2x is equal to 6. Therefore, x is 6 divided by 2 is x is 3. Okay. And then over here, I'm going to add 3 to both sides, which gives me that 2x is 0. Dividing by 2, I get that x is 0. So my answer is 0 and 3. And I can go back to the original problem, right? And I can see, well, if I put a 3 in there, I get 6. This becomes 6, and 6 minus 3 is 3, and 2 plus 3 is 5, so that checks. And if I have a 0 in for that x, 2 times 0 is 0, and the absolute value of the negative 3 then would be 3, and 2 plus 3 is 5, so that works all the way around. Okay, how many more problems we got? This looks like it's the last one. Hey. So to determine if the triangles below are congruent, if they are, justify your answer using one of the triangle congruence conditions and state a sequence of rigid transformation that maps one triangle onto the other. Okay, great. So if we look closely, I think that we see that these two triangles are congruent by side angle side, right? It's not marked congruent, but clearly it is the case that segment BD is congruent to itself, BD, because of the reflexive property. And with that, I should put like 3 tick marks on that. So with that, in the upper triangle, you can see I go from A, then to B, then to C. So you can see it's along this side and here. And then down below on the other triangle, you can see I'm going from C to the D to the B. So they definitely are congruent to each other. Now the question is, what is a series of rigid transformations that would map one of those triangles onto the other? So I think, yeah, I think I would do this. I would say, I'll write it out what I'm saying. I'm going to say translate LATE point D to point B. So I'm going to take this point D and I'm going to move it until it's lined up perfectly with B. I'm just going to translate point D to point B. Then I'm going to rotate the bottom triangle, triangle CBD or CDB. I'm going to keep rotating this around um, until DC is lined up with AB. Until DC line, or I'll say until DC meets. Hello, I'm DC. Until DC meets segment BA. What does that mean? DC would meet segment BA. Yeah, until they meet. And that's how I would translate that so that the triangles lined up perfectly. And did I mention that they were congruent by, I didn't write it down. They are congruent by the SAS congruence condition. All right, class, that's it. See you in class tomorrow. That was the last question. I hope it was.